Welcome to the Math Record. Today I'll be covering the basic idea of derivatives. In the previous video, we came up with a formula to find the derivative, so let's use that to do an example. So we used a parabola in the previous video, so let's just use a parabola now. So let's say f of x is equal to x squared. So just a really simple parabola. So using our formula, which was the limit as h approaches 0, we have f of x plus h minus f of x divided by h. Okay, so let's plug that in. So x plus h into our x, so that's going to be x plus h squared minus f of x, which is x squared, divided by h. And don't forget the limit. Simplifying this, the limit as h approaches 0. So this expands out to x squared plus 2hx plus h squared minus x squared divided by h. Simplifying that, the limit as h approaches 0. So x squared minus x squared, that's 0. So we're left with 2hx plus h squared divided by h. Simplifying that, we have the limit at h approaches 0. 2hx divided by h is 2x. And h squared divided by h is h. So the limit as h approaches 0, that means this h becomes 0. That means all we have left with is just 2x. And this equation is going to be our derivative. Specifically, it's called the general form for a derivative because it's going to help us get the derivative of any point we want. So let's delete this. So this was our original equation, and our derivative is 2x. So let's try to understand what this is actually doing using an image. And okay, so that's a little bit too much. Let's say somewhere right here. Okay, so we have some kind of parabola. Not really good drawn, but it's fine. So let's say we call this point x equals 1. So how do we find the derivative at this point? Well, we just need to plug it in. We found our derivative of our equation. So if x is equal to 1, then 2 times 1 is 2. So that means if we draw a tangent line, then the slope of this tangent line is going to equal 2. And if you want to find the equation of this form, well, this is just going to be a linear line. It's always going to be a linear line. So it's going to be y is equal to our slope, which is 2, x minus, what's the x value? 1. What's our y value? We'll just plug it in. So 1 squared is 1, so plus 1. Let's try another one. Let's say instead of x is equal to 1, let's say x is equal to 2. So x is equal to 2. Well, now we need to find the derivative of this point. So this obviously looks steeper. So is that well, is it actually steeper? Well, 2 times 2 is 4. So obviously it's steeper. Mathematically proved. So y is equal to our slope 4, our x value, which is 2, so x minus 2, and our y value, plug in 2 into our equation, so 2 squared is 4, so plus 4. So this is the equation of our tangent line for x equals 2. And you could do this for any point in this curve, any point. So even if you choose a negative, we could do this. We choose something here, this, and we choose a point even at right here. It's like this. And it kind of looks like it's 0, which it is, because if x is equal to 0, 2 times 0 is 0. So the slope is 0 means it's just a constant line. Okay, so now that we know how to find a derivative, it kind of now dawns on us that it's really tedious to just keep using x plus h and simplifying each time. So calculus speeds up this process by using a few rules. And the first rule, and the most basic, is the power rule. And that basically says that if we're given a function f of x in the form where it's x to some kind of power, so let's say n, or n is just some kind of number, then the derivative at that point is just going to be the constant n. So just move that number down, multiply to n, the power of our, our power at is minus 1. And that's our power rule. So let's try to use some examples. So let's say we have f of x. Instead of a quadratic, let's say cubic. And let's say it's not even an integer anymore. Let's say it's a power of 3/4. And let's try one that's not even positive. Let's say to -3. So the power rule gives us the derivative. So the derivative, you're gonna, with a notation as like an apostrophe. There's also another notation which is called, I think it's spelled Leibniz. I probably butchered his name. Leibniz notation, which is d of dx, instead of using apostrophe, but you could use either anyway. I prefer using apostrophe because it's easier. Leibniz you're going to use later on for implicit differentiation, so you don't have to worry about that for now. But they both mean the same thing. So using the power rule for this, we put the number down, so put 3 down, x, and then subtract 1. So 3 minus 1, 2. Okay, that's done. That was pretty easy. Let's do this one. So put the number down, so 3/4, x, subtract 1 away, so 3/4 minus 1 is -1/4. Okay, so that was easy. Next one. So put the power down, -3, x, subtract 1 away, -3 minus 1, -4. And we're done. So we just found 3 derivative really quickly using the power rule. Now let's add a few properties about derivatives. So derivatives follow the basic addition rule, which basically says that if we have two functions, f of x plus g of x, and you put them together and then you take the derivative, it's the same thing as doing the derivative of each of them and then adding them together. And that's the same case for subtraction. So if you have a function minus another function, take the derivative, then we're going to have the derivative minus of one of them minus the derivative of the other. So the derivative of the things put together is just the derivative of each of them separate. And then there's one more, which is scalar, which deals with basically a number multiplied to a function. And if we take the derivative of this, you could just ignore the constant and then just take the derivative of your function. And then there's basically one more called a constant, which is the simplest to remember and the one that you're probably going to use the most. And also because it's the most frequent and usually every function has it. So if we have a constant and we take a derivative of it, it's 0. So if you take the derivative of 5, that's 0. If you take the derivative of, let's say, 1,000, that is 0. If you take the derivative of 1,000,000, that is 0. So any derivative of a constant is always 0. Unless there's some variable in it, then that's you're gonna use addition, subtraction, scalar, power rule, etc. And some other rules that we're teaching later in the future. But basically, those are the rules. So let's try an example that uses all of it. So let's say we use a more complicated parabola. So f of x is equal to 2x squared minus 5x plus 3. Well, we want to find the derivative. So what's the derivative of 2x squared? Well, ignoring the 2, what's the derivative of x squared? Well, that's 2x, using the power rule. Take the 2 down, take 1 away, means 1, so 2x. Minus, So keep the same things down. So if it's a minus, we keep the minus down. So what's the derivative of 5x? Well, that's just 5, our constant. What's the derivative of x? Well, using the power rule, right? Move 1 down, take away 1, that means x is 0. X is 0 is 1, so 1 times 1 is 1. So it's just 5 times 1. And then plus the derivative of 3, that's a constant, so that's 0. So simplifying that, 2 times 2x is 4x, and 5 times 1 is 5, so minus a 5. And adding 0 does nothing. So the derivative of 2x squared minus 5x plus 3 is 4x minus 5. And that's basically it. So in conclusion, in this video, we covered the power rule and some rules like addition and subtraction. In the next video, I'll deal with multiplication, division, and this really cool concept called chain rule. Well, thanks for watching.